Lester Martin, and I want to take a few minutes and just give another, maybe super in a nutshell, representation of something you might have heard about called RAG. And you might have heard it a few times, but if you're still looking for a good, quick understanding, hopefully this will tackle it for you. So as we think about this RAG, it's really about the fact that we have these large language models out there that we can ask questions of. And when we ask those questions, they only have the information they were trained on, which is basically all the information that's publicly available on the internet and other sources. But when we have to ask a question that's maybe the context, we need more information that our enterprise or company or organization, whatever, has internally. How might we leverage that? And that's really what this retrieval augmented generation is all about. It means we're going to go take a question, we're going to go look up in our own internal storage systems, find some additional details, and then we're going to supply that to the large language model and say, hey, knowing this additional information, here's a question I have, and get an answer. Pretty simple stuff. The problem is, and I'll go ahead and show you my next slide, is the problem is, how do you find things that are similar to what you already have? And I'm really talking about here binary files. I'm talking about PDFs and presentations and spreadsheets and documents like Word and Google Docs, etc. And how do you take all that unstructured information, all that mass amount of text and pictures and everything, and get them to the point you can say, find me some information that looks a lot like this. You can't do that with good old-fashioned table-oriented, column-oriented SQL that you might know and love. We have to introduce this concept, often referred to as maybe a vector database or embeddings or vector embeddings. And what they really are is they are mathematical representations of a word, or in our case, probably a chunk of text. So maybe a paragraph or two out of an internal document. Maybe we grab all these paragraphs and break them into pieces. We might call them chunks. And then what we want to do is we want to store those, but before we store them, we have to vectorize them or make an embedding or embeddings out of them. So not going to go into the math of it. Just assume there's some kind of numbers and multi-dimensional numbers, actually thousands of dimensions usually. And what they do is once those mathematical representations are created, we store them in some kind of system that could understand all that. And this picture, what it's trying to show is, well, what if there was 3 dimensions, X, Y, and Z, instead of maybe 1,000 plus dimensions? And what if we just talked about a word instead of a whole sentence or paragraph or section of a document? But those vectors, what they end up doing, they start to look similar to each other. Just like you see a sandwich and a hamburger, maybe those were definitions of a sandwich. A sandwich has 2 pieces of bread, some meat in the middle, probably has some kind of condiments. And you know what? That looks a lot like a hamburger. So they're pretty close together where they live in that vector space. But a hot dog, its description sounds a little like it, but not quite as close, mainly around the bun. It gets a little confusing. There's just one bun and that kind of stuff. So what you try to see with these color codings, what I'm trying to show you is there are some natural things that just kind of live a little closely toward each other. I don't need to go into each one of those, but I think you can visualize those. Maybe I'll just talk about the very last one, the one on the bottom right. There are some vehicles. There are some human-powered vehicles like bicycles and unicycles that look a lot alike at a car. And these mathematical representations of a description of a car might look close, but not quite as close. So this is what they call vector embeddings, again, in an extreme nutshell. And these get stored in some kind of special, historically special database called a vector database, even though I think there's a variety of things happening in the text space. All right, so we take our docs and break them apart. And really what that means is we have to think about those documents, those PDFs and spreadsheets and docs, etc., differently than maybe a flat file of records or a topic like Kafka or message queues come in. We have to actually go out to those repositories, SharePoint. We have to go out to Google Drive, etc., and start noticing docs are changing. So kind of a CDC model. There's some change happening, and we'll grab that doc, and then we have to go through that work. We have to break it into pieces. We actually have to parse it, make it look like a big text thing only. So convert all the graphics to words and convert little tables in stream and all that stuff. Make a big long text doc, usually in a JSON format, and then decide how we want to break it into smaller pieces. Those are our chunks. And then for those chunks, again, maybe think of them as a paragraph or two. That's a chunk or a section in a formal document that has 1.1, 1.2, that kind of stuff. We'll push that against some kind of piece of code. So we're going to use these AI models to help do that, to create some embeddings. So create the mathematical representation, and then store those in some kind of vector database or vector persistent store. Then we could build that RAG app that we talked about. A customer, a person, a question, maybe it's a chat bot, asks a question, your application, and your application can now say, hey, take that string, that message they said, vectorize it, create a vector embedding, and then go look in that database, that vector database, and say, find me some similar chunks of text that look like this, that are related to this in some manner. You'll retrieve those back, and then we'll just send those to the large language model. We'll say, hey, knowing this information that I'm giving you, that's the information that the LLM, the public LLM, won't know about. Knowing this, what's the answer to this question that my user's asking? And then we'll simply just hand all that back. A very simple concept of what a RAG application is. And if we put it all together just to make it look like a lot on one picture, there's the pipeline, the ETL pipeline, as well as the RAG application all in one place. So, hey, I hope that helped a little bit explain it. Again, looking for, in a nutshell, overview. I know it wasn't make perfect sense to me the first time I heard that, but hopefully this helps some. And if it doesn't, or if you got some questions, definitely drop in the comments. I will be looking for them, and I will do my best to reply to them as well. Thank you.